This is a separable differential equation. So notice that here we are not required to find the domain. I guess you could do it, but it's just a bit challenging. So here I decided not to make it an objective of the question, right? So let us do it. So the first step is to separate the variables. So we are moving everything with y to the left-hand side. Then we are going to get dy over y cubed on the left equals sine t plus t dt on the right. So then we are going to integrate. The antiderivative of d of 1 over y cubed is minus 1 over y squared. And I think you need to do divided by 2. So now if you, this is correct. This is the antiderivative of sine is minus cosine t, right? Plus t squared over 2 plus some constant. Okay, I guess we could just simplify it a little bit. I don't know, get rid of 1 over 2. So then 1 over y squared equals 2 cosine t minus t squared. Well, strictly speaking, it should be minus 2c, but 2c minus 2c or c is, in either case, it is an arbitrary real number, so I'm going to just write plus c, because this is plus an arbitrary real number. All right, then we need to find the constant. So how do we find the constant? So to find the constant, we use the initial condition. So the initial condition tells us that, okay, the initial value of y is negative 1 over 7. So its squared is 1 over 49. Reciprocal is 49 equals 2 cosine 0 minus 0 squared plus constant. So my constant is going to be equal to what? 49. Cosine 0 is 1, so minus 2, which is 47. All right, so I'm just going to write plus 47 here. So this is 1 over y squared, so which means that y squared is going to be the reciprocal of this, 1 over 2 cosine t minus t squared plus 47. So which means that y is going to be plus minus square root of this. So 2 cosine t minus t squared plus 47. Is it plus or minus? So we need to find out. So notice that the initial value of y is negative, right? And then if we let t be 0 here, then we see that the square root is positive. So in order to make it negative, we need to keep the negative sign. So which is why the answer is negative, because the initial value of y is negative. And that's really it, because here we are not supposed to find the domain of the solution. So if we wanted to find the domain of the solution, then we would have to find all values of t for which the expression in the square root is positive. But it's just that in this case, I don't think that you can do it in closed form. I mean, you can roughly plot the graph and see roughly, but you can estimate the values of t, but you cannot really solve it explicitly. So which is why it is not a goal of the question here. So that's the final answer.